We're going to look at matching a graph to an equation in general form. In general form, of course, doesn't give us much information. It's a very formal type of line, the hoity-toity kind, I consider it, for when it comes to equations. And so what we can do is look for the x and y intercepts and match them to the graph. So if we're finding the x-intercept, we have to let y be equal to 0. And so that would give us 5x, and then this term would now be 0. The 4y would now be 0. Subtract 20 is equal to 0. 5x would equal 20, and of course that would give x equal to 4. So our x-intercept for this equation is going to be 4. That gives us with either option A or option C, as the other two graphs do not have 4 for an x-intercept. If we find the y-intercept, we're going to let x equal 0. That would give 5 times 0, which gives this term to be 0, and we're left with negative 4y subtract 20 equals 0. So negative 4y is equal to 20, and y would be equal to negative 5. So our y-intercept would be negative 5, and that would leave us with option C. Another way to do this is to take the general form and rearrange it into slope-intercept form. So if we have 5x subtract 4y subtract 20 equals 0, we can rearrange it to figure out what the slope and the y-intercept would be. Negative 4y would equal negative 5x plus 20, and y would equal negative 5 over negative 4x subtract 5. And here we would see that the slope would be 5 over 4, and the y-intercept would be negative 5. Slope of 5 over 4 is a positive slope, so we know it wouldn't be D, and we know it wouldn't be A. And a y-intercept of negative 5 would give us one of these, but the slope must be 5 over 4. 1, 2, 3, 4, 5, and over 4. And here's our answer. So there's two ways that we could match the graph to an equation in general form. We could rearrange it so it's in slope-intercept form, or we can determine the x and y intercepts and match it to the graph that way.